So here's another one like that. Integral from 1 to infinity of 1 over x squared. So the idea is we're going to rewrite this as the limit as b approaches infinity of the integral from 1 to b. And let's go ahead and write the integrand as x to the negative 2 dx. Yeah. Okay. And then so that is going to equal the... Is that what I want to do? Yeah. Here we go. Let's get a little lost. That's equal to the limit as b approaches infinity of... so this antiderivative is going to be negative 1 over x from 1 to b. So that equals the limit as b approaches infinity of negative, plug in the b, negative 1 over b, and then it's going to be minus negative 1, so let's go ahead and put plus 1. So that's going to be the limit as b approaches infinity of negative 1 over b plus 1, because the 1 is just constant with reference to the variable of the limit, which is b. All right, so b approaches infinity. We have 1 over b, so numerator is bounded, denominator increases without bound. This limit is 0. 0 plus 1 equals 1. Hey, So if we look at this graph, so this is 1 over x squared, right? So 1 over x squared looks like this. All right, and if I do the integral from 1 to infinity, so that's the integral from 1 to infinity, it's going to be this over here, right? And this area over here equals 1, according to this. This area over here is 1. All right, but look what we found out over here. We said that the integral from 0 to 1 of 1 over x squared is infinity. So this area over here, is infinity. Yeah, that's pretty weird. Break this graph at 1. The area over here under this vertical asymptote is infinity, but the area under this horizontal asymptote is 1. I'll be darned. Well, let's look at some other improper integrals that have weird stories like that. Like, I could actually probably just let you sort of try these. You probably should. So let's see what you can find for the integral from 1 to infinity of 1 over the square root of x dx. So all right, I'll just remind you that that's equal to the integral from 1 to infinity of x to the negative 1/2 dx. All right, and then the other one we're going to find is the integral from 0 to 1 of 1 over square root x dx. So we're going to do the same thing we did with x squared, right? What's the integral from 0 to 1? What's the integral from 1 to infinity? So this one we can rewrite as integral from 0 to 1 of x to the negative 1/2 dx. You can go ahead and figure out those integrals. Meanwhile, I'll sort of sketch what the graph of this looks like. You can sketch graph of 1 over square root x. I think we already have that. We already have that somewhere. Let's see what we got here in our Desmodio. Yeah, we got x to the negative 1/2 right there. X to the negative 1/2 power, that's this integrand, all right? That's what the graph looks like. So how do you think it's going to break down this time? All right, well, I guess we have time. So you pause, do that, and come back. All right, so I'm going to assume you already did this or took your best shot at it. Let's see how you did. So this one equals the limit as b approaches infinity of, so the antiderivative of this is 2x to the 1/2. And we're going from 1 to b. So that is the limit as b approaches infinity of 2 square root b, writing the x to the 1/2 back as a square root, minus, let's see, if I put in the 1, I get square root of 1 times 2 is 2. 2, okay, so that equals the limit as b approaches infinity. So we're getting the idea that the limit only affects the part of the antiderivative that has the variable in it. So the limit is b approaches infinity of 2 square root b minus 2. All right, well, if I have a variable going off to infinity and I just keep taking the square root of it. Well, one way to think of it is the square root of b is an increasing function. So as the b goes off to the infinity, so does 2 square root b go off to infinity, to positive infinity on the y-axis, where that's really happening. All right, so this is infinity minus 2, which for the same reason infinity minus 1 is equal to infinity, so is infinity minus 2. That's infinity. If we look at this graph, which I had sketched out before, here's our graph. It sort of looks a little bit higher there. All right, so now this time, as I go to 1, this side is infinity. So this bit over here is infinity. What about this bit in here? Well, that is equal to the limit as a approaches 0 from the right of, and let's go ahead and put our antiderivative right away. It's 2x to the 1/2 again, 2 square root x if you like, a to 1. So this is going to be the limit as a approaches 0 from the right of, when I put in the 1 first, I'm going to get 2, minus, then I put in the a, and I get 2 square root a. All right. Now, the limit of 2 is just going to be 2, and then I have minus limit as a approaches 0 from the right of 2 square root a. Well, this time, for it's the same graph, but I'm approaching 0 instead of approaching infinity. So this is approaching 0 equals 2 minus 0. It's 2. This area is 2. So remember that this graph goes infinitely far in both directions as it asymptotically approaches the axes. On this side of this integral, I got 2. On this side, the area is infinity. It's infinite. All right? That's for 1 over square root of x, right? This is y equals 1 over square root x. 2 on this side, infinity on that side. Now, compare that to this one. This is 1 over x squared, infinity on this side, 1 on this side. Pretty weird, huh? All right, we'll look at, what are we going to do next? We're going to look at some more different examples. Okay, that's what we're going to do next.